In 2011, social psychologist Darrell Bem published a study on feeling the future. In the study, Bem hypothesized that humans have the capacity to feel the future, and with 8 out of his 9 experiments yielding significant results, it would seem he proved that to be the case. To be more specific, the experiments tested for evidence of PSI, which refers to information or energy transfer currently unexplained by known mechanisms. This includes phenomena such as precognition and premonition. Let's take Bem's first experiment, for example. He set up a simulation exposing human participants to 2 curtains and asked them to pick which curtain they think a picture is behind. After they took their guess, the computer placed the image randomly behind one of the curtains. Bem hypothesized that people would be able to correctly predict the curtain behind which the image would be placed, at a rate significantly greater than chance, or more than 50%, indicating an ability to feel the future. With this experiment and 7 of the other 8 experiments producing significant results, it looked like maybe people could indeed feel the future. However, further analysis of the results reveals several issues. Firstly, harking techniques were potentially used in the first experiment, where the null hypothesis was established after data was collected. In this experiment, precognitive perception of erotic images, negative images, and romantic but not erotic images were tested. A hypothesis could have been established that humans have some precognitive awareness of any of these stimuli, but Bem decided only to hypothesize that precognition existed for erotic images, which was the only one of the 3 hypotheses which provided significant results. Bem justifies this on the basis that perception of an erotic experience could provide an evolutionary advantage, but it's not clear as to why this would not be the case with the ability to avoid negative stimuli. Furthermore, a significant issue with Bem's interpretation of results is that it ignores the prevailing evidence regarding PSI in existing literature. This essentially comes down to the fact that in science, extraordinary claims require extraordinary evidence. And in the case of PSI, the pre-existing evidence overwhelmingly suggested that it doesn't exist. So Bem's study would have required very convincing evidence for the field to adopt the belief that PSI does exist. This is why the use of a traditional one-tailed hypothesis test at a 1% significance level provides misleading results. Given that the existence of PSI is an extraordinary claim, the study can't be considered in isolation, and a small p-value is not necessarily sufficient to reject the null. After all, how likely are you to believe something to be true based on one study, when all pre-existing evidence suggests the opposite? The Bayesian rule can be used to incorporate the existing evidence into conclusions about the probability that PSI exists. The Bayesian rule essentially finds the posterior probability, or the probability of the hypothesis that PSI exists given all the evidence up to and including Bem's study, by adjusting the prior model odds that PSI exist by the Bayes factor, which in this case is essentially the new evidence introduced by Bem's study. An example can be used to show this. With PSI having no mechanistic model as outlined by Price, and the inability of natural selection to lead to a world full of clairvoyance as discussed by Kennedy, prior evidence in support of PSI is negligible. Following the example outlined by wagon makers, the prior odds can be expressed as 1 by 10 to the negative 20. To be generous, we can use the scenario where Bem is able to obtain strong evidence. Under the definition proposed by Jeffries, the data is unlikely under H0, but likely under H1, with a Bayes factor of 19. This is commensurate with a posterior probability of 1.9 by 10 to the negative 19, meaning that even after Bem's study, the likelihood of PSI existing remains extremely slim. Moreover, the results of Bem's experiments have not proved reproducible under multiple attempts. For instance, one study attempted to exactly replicate Bem's 9th experiment on retroactive facilitation of recall, and statistically significant results weren't attained. These difficulties in replication potentially indicate underlying problems in the experiments. And one such problem is with sample sizes, in that smaller samples produce more compelling evidence. In fact, a study from Alcock found a correlation coefficient of negative 0.91 between the sample size and the effect size, which is evident in how experiment 9 yielded a p-value equal to 0.2%, while experiment 8 yielded a p-value of 2.9%, despite being otherwise highly similar. This could be indicative of data peaking in smaller sample sizes, where data collection is ceased once a significant result has been achieved, as seen in the table comparing Bem's p-values to sample sizes. By proving the existence of something widely believed not to exist, Bem's paper created uproar in the scientific community, and it shows how inappropriate treatment of data can lead to statistically significant results that might not give a perfect representation of reality. The fact that Bem's study supposedly broke science reminds us of the need for care in statistical inference, and to be wary of the conclusions we develop.